Okay. Hi everyone. Today, I will share an interesting paper that I found recently, which is called LLM Get Lost in Multi-Turn Conversation. And this is actually a very simple but pretty common case in our daily usage of language models. Modern language models like ChatGPT or Gemini or Cloud, so they are fundamentally a conversational system that's being used in our daily. But uh, During their development, they are mainly evaluated on the benchmarks, which is by the time that this paper was published, it was at the environment that uh, a lot of there is no many multi-term benchmarks. There are the language models are mostly evaluated on the single term and fully specified instructions. But this is actually pretty different in our with our daily usage because language models are used by human mostly with multi-turn conversation. And in human instructions, they are pretty common that under specification occurs, which means that if I want to tell someone else, I'm pretty common. It is pretty common that I tell something and then gradually add more well-rounded explanations, rather than just have a single term fully specified environment. This paper is mainly talking about these two difference, which is single turn input with multi-turn interactions. And I will explain the results first. I think it is really like as we expected. So language models that evaluate on single turn settings uh, drops a lot in their performance when we move to multi-turn. And this paper formalizes two concepts, which is aptitude and unreliability. So we will explain this later in detail. So the result is that multi-turn looks pretty hard than single turn. Let's talk about the paper contribution first. This paper makes three key contributions. So first, it introduced a new evaluation framework called shared simulation, which transforms a fully specified instruction into smaller pieces and reveals them gradually across conversational turns. So this enables a more realistic real-world settings. And second, it proposed a shift in evaluation metrics. Previously, most settings are focused on the accuracy on benchmarks, but this paper is mostly focused on aptitude, which is the top task solving ability, and reliability, which is the consistency across turns, which allows us to better understand how the language model works. And third, it formalizes this pretty weird phenomenon. I think if you are like using the ChatGPT a lot, you may find that with like you talk more with it, the instruction following ability is quite not as well as the start. So let me explain the core idea of their method, which is also very simple. They call it shared process. So usually we have a single term prompt during the benchmark, but what they did is they break it into the uh, shared pieces and gradually feed to language models one by one. And we can see there is an example that there is a fully specified instruction, which is very usual. But what they did is they break it into shared forms, and then they want to apply it in the multi-turn setting. And after splitting the instruction, so what they did is they simulate a multi-turn conversation between a user and the model. So at each turn, the user reveals at most one shared, and then the model generates a response, which is classified to see whether it is asking, clarifying, or attempting an answer. And if the model gives an answer, then we extract it and evaluate the correctness. If correct, then the simulation is end. Otherwise, we continue the loop. So this setup let us to track not just about the final accuracy, but how the model behaves and adapts across turns in a realistic conversational setting. So they have few simulation types. The first and which is the fully specified single turn, and this is just the usual setup. Also, they have shared, which is reveals the pieces of instructions one by one, and also they have concate, which is just concate those splitted shared instructions back. Later, they will do a comparison between full and concate, but that was kind of an ablation study regarding the information loss. So we will also talk about that later. And also for recap, recap gives the model a final chance to by summarizing the previous informations at the end. And the snowball is progressively accumulates and repeats all previous information at each turn. So for the test setup, so they mainly do this kind of multi-turn evaluations in their simulation environment across six type of tasks, which is some code database and action tasks, and also some natural language and logics such as math, data to text, and summarization task. And we can see these examples on how they like break the single turn prompt to multi-turn. So they did very big experiment. As we can see, they tested over 15 language models and many types of conversations. And they use temperature one, to measure the variability and across runs, and they also set up the evaluations based on this. And for the matrix, they introduce three matrix. The first is really common, so the performance is just the average score. And the other two is they introduced based on their work. So the first is aptitude, which measures the best case performance using the top 10% results. And also the unreliability measures how much the performance varies by taking the difference between the best and the worst cases. So for example, even if a model can sometimes get 95, if it also gets 30 in another run, then this means it's really unreliable. And the interesting finding is that in multi-turn setting, unreliability increased significantly. So here is a diagram of aptitude and unreliability. So the loss in aptitude means the model's ability to solve the task decreases. But later they found that the aptitude doesn't decrease that much. And the increase in unreliability means the model become inconsistent and harder to trust. So this is the part that their experiment shows. In multi-turn setting, the unreliability increase a lot. And here is the results in numbers. Uh, since this is really a lot of numbers, so we just highlight the key idea. So the right part is the degradations. And we can see that from full, which is a single turn prompt, when we break it to multi-turn, the degradation increase a lot. And we can also see that uh, in single turn prompt and the concate, which which is the set of all multi-turn instructions, uh, this degradations doesn't occurs that much, which means that which they suggest that this drop is not mainly caused by the losing of information during the uh, prompt splitting, but rather by the multi-turn interaction itself. So let's first interpret why performance drop. So according to the paper, there are four main issues. So the first one is parameter answering, and the second one is over reliance on the incorrect past answer, and the third one is over adjustment to last turn, and the last one is there are too many assumptions in previous conversations, so we can see it one by one. So premature answering is that the model answers before enough information is revealed. So at the beginning of a conversation, the model has very limited information, but it still tries to generate a full answer. So this often leads to incorrect assumption being introduced early on. And once those assumptions are made, they tend to stick on them, and those influence later reasoning, making it harder for the model to recover it back. And also, over reliance on past answers is also an issue. So instead of correcting itself, the model keeps building on its previous response, even when they are wrong. So this causes error to accumulate over time. So as a result, the answer becomes longer and more complicated, but they are not necessary to contribute to the correctness. And we can see that this phenomenon occurs across many kinds of task types. And also, the model relies pretty much a lot on last turn. So the model tends to prioritize the most recent user input, sometimes at the cost of like ignoring earlier information. So this leads to forgetting important context from previous turns. And this is kind of similar, like the model got lots of the information which they didn't pay attention that much equally. And the last is over verbosity. So as the conversation continues, the model generates longer and longer response. But these longer answers often include extra assumptions during the model reasoning process. So instead of improving performance, I actually this idea make things worse because the model drifts further away from the original task it's supposed to solve. And also, we can also take a look on the amplitude with unreliability. So we can see that aptitude, we first recall that aptitude refers to the model's best case performance, which means how well it can do when everything goes right. And unreliability measures how much the performance varies, whether the model is consistently being consistent. So this figure shows that the loss in aptitude is not that much compared to the loss in unreliability, which means in multi-turn settings, so the model still have good ability to solve the task, but the issue is they're kind of not consistent, so they varies a lot. So this is kind of the issues. And also, we may also wonder that uh, is that because the job is because we split it to too many unnecessary turns. And they also did an ablation study on this. And we can see that they gradually increase the number of shares. So from one share, so the first is their single turn prompt. Even with just two turns, the performance already drops a lot from the first to the second. So this tells us that the main issue is not about the number of turns. So the problem is that once we enter a multi-turn setting with incomplete informations, the model already starts to struggle. And that's why they conclude that the main cause is that multi-turn interaction is kind of caused by the under specification, but which under specification is kind of common in the real world deployment. So let's move to the summary. So I think this paper doesn't is not a very technical focused paper on the technical innovation, but they reveals an interesting part, which is how language models performs when instructions are incomplete and revealed gradually. So they formalize this problem, and they also use shares to simulate a gradual information reveal that uh, does not so fundamentally for the monitor for those issues that make the performance worse. And we can and their paper by their experiment and the performance drops a lot versus a singleton. So this is kind of an unreliability issue. So the takeaway of this paper is that I think this paper was established last year. So at that point, so I believe that current language models are still need to improve in multi-turn settings, and we should also focus on optimize for the reliability, which is variabilities across different usage, not just the very top performance. And we may also need to upgrade the conversational system along with the language models because the system that interacting with the language model is also important to make the overall conversational experience better. And also, this paper also have some limitations. So first of all, the conversations they used are simulated by another language model, which is not exactly identical as human interactions. And another thing is that their evaluation only focus on the task that is kind of like analytical, but not those open-ended tasks. And the third one is that they only have English tasks, so it doesn't know like whether it works in other forms of languages because they are still like kind of different in different languages. And they only do the last one is also important. So they only did on natural language processing tasks and rather than in multi-model settings, which is more relevant to real world setting. And yeah, I think that's all about my presentation today.